So today we are going to understand this what is DevOps and how the DevOps would be and how it's going to helpful this the DevOps. Yeah, there are the points we are going to talk at this. So this total this demo to understand it, the importance of the DevOps. So which we need to spend that at least like 3 to 4 hours to understand the complete things. But to understand it, first today we have this some concept, and tomorrow we have the some concept, and the next we have this another concept. So like it has been divided into this demo itself like 2 or 3 sessions. So we go for this in this entire demo. So what is the DevOps and why DevOps, and then what are the delivery challenges we have this in the DevOps, uh, the process point of view, and Agile and DevOps is what is the need of that Agile, and why do we need to understand this the Agile. So that's points. And so we have the some release concepts and understanding about the DevOps and where's release management. And this DevOps, when do we use it? That means in which infrastructure that can be used, and which is not recommended for this which type of infrastructures. Yeah, so there are the points that we are going to talk at that. Uh, this demo's point of view. And before starting about this, let me talk it about that taking this one project, and that project, how does the evaluation we have this evaluation we will discuss it, and then we try to understand that in that the life cycle of the projects. So what are the main issues that we have that. Yeah, so yeah, so in the organization, if you just take it about it, so any kind of the applications to implement it, like we have that different types of this application, like web applications and mobile applications, and as well as like a socket-based applications. So any project, if you take it, any application implementation, if you take it, so almost all work is done as a project. So that's like as a project. And so the project, whenever they start about it, so each and every project is having this the plan, the specific plan that is suppose if you just to take this the example, like the Gmail application is that the web application, if it is required to implement it, that means from scratch onwards to start that application, which is having the some specific plan for this. First, they decide about this the what is the tenure of it, like is it required to implement this application 1 year or 2 years or the 3 years or the 6 months project, or is it like a 2 months project. So the first plan they come up with this the project plan, and once the plan is decided, then which we have the executing, like so is it so implementation we have this, and the testing points we have this, like a complete executing about it. And then the inspecting, that means quality verifications, the quality of this the product or application verification, and finally accepting and launching that application to the live environment. Yeah, so these are all the stages that we have. Suppose if you are working for that, the mobile applications, or if you are going to work for this, the web applications. So any project or any application, if you take it, that application which will be evaluated as a project, and the project which is having this the plan, execution, inspecting, and accepting model. So but how, who, which team is going to handle this all these models? So like a planning, who is planning about this the projects, or who is executing the projects, or who is going to take care of this the inspecting and accepting? So we have the project management team, so which are coming into the picture, the project management. So they have this the practice models or the methods or the tools they use it for this project management purpose. But objective of this the project management team is all are about delivered on time and on budget. So this is the important thing which we need to understand as a DevOps engineer. So this is the main objective of this the projects which are we are working this in the organizations. So any project is there is nothing but that a project is required on time, it has to be delivered to the customers and with on budget. Yeah, so this is the main objective of this the projects. But this project, so we are saying about this the different methodologies they use it. But what are those different methodologies, and so what is the life cycle of this the complete projects that we have this? So we try to understand that point, that means the process will try to understand it. So in each process which teams are involving that, that's the teams also will try to understand it. Then we go for that, what are the disadvantages we have, that why we are not able to deliver the project with on times, or why we are failing this the projects in the organizations. So we try to understand some problems, and those problems, so how it can be overcome that by launching about or introducing the DevOps. So first, what we are trying to understand is, so traditional approaches we are trying to understand, because so already in the market we have the projects like if you take it as the domains, telecom domains are available, banking domains are available, insurance domain projects are already available, or like healthcare domains, or I mean education domains. So all these domains related applications are already available. So the DevOps is not the new project. You are not going to apply that. If you are going to apply these tools, new projects, then we don't get the much opportunity, or we don't get the good career on this technology. But the DevOps process is supporting the existing projects also. Already we have so many projects, so many applications, so many products in the market. But from those existing environments or existing projects, what are the problems we have that? We'll try to understand this first. Those problems are happening this. So why these problems are happening this, we'll try to understand the second point. Then how the DevOps is going to helpful the problems which are others in the infrastructure to overcome that. So there are the 3 points that we are going to understand as in this entire the process. But what is this the exact project, and what are the life cycles we have this? So this life cycles we'll try to understand it. So this is a complete development life cycle of the project. Most of this the projects which they use it, but what is this in that life cycle, what is the first phase? So the first phase is which we consider as requirements. So that means once a project is decided, the project related complete requirements that will be gathered, like collecting this the functionality of that application. So there is which is collected by the separate teams, which we can say business analysts, which are coming into the picture. And this requirements is going to have some specific duration. So there is 1 month or 2 months on some specific duration. And once these requirements have been analyzed, and the next team which is coming this is, that is the designing teams which are coming in the project life cycles, that is the system level design, and as well as which we have this like a programming level design. So why we have the 2 types of the designs? Suppose just to take this example, just always whatever I'm talking about it. So just keep this in Gmail application is that the I mean internal meaning of that. Suppose Gmail application, if you take it as a application project, so the first complete requirements it is required to gather it. They were gathering this the complete requirements. Then they have designed this the application with the programming point of view, infrastructure point of view. Then that the developer they have come up this and implemented. So that is already evaluated, but we'll try to understand that example. So the Gmail application complete requirements, and then the Gmail application is required to design it, the system level designs and programming level. But what is the difference between the system level design and programming level design is, the system level design which we can say like suppose if we are hosting the Gmail application, so we need to have the system. So without having that the operating system, without having the RAM capacities, or without having like the storage capacities or the databases, we cannot deploy the application, or we cannot access the application. So there's complete infrastructure which is required to set up that, like how many servers that is required, because millions of the users are going to access that application. So whenever the millions of the users are accessing that, so you should not just keep this on one system. So we need to have the thousands of the servers. So how many servers that is required? That is the system level design. But once this the system the complete infrastructure is designed, then the application functionality also they need to come up with this designing approach, the functionality of their application. That is the programming level designs. So the 2 types of the designs, infrastructure architects are coming into the picture, like how many servers that is required to set up, and what is the RAM capacity, what is the storage capacity, what is that like a processor capacities, or which servers that is required to use it, which database is required. I mean, that's kind of the complete the designing, so which will be done by this infrastructure team. And then suppose Gmail login page is there, login page. So how do we implement it, and what are the fields that is required for the login page? Once the login page is submitted, the home page of the Gmail, how does the look and feel of this the home page, and what are the options that is required in the home page? This is the programming level design. This is the functionality we call that. Yeah. So two types of those architects are coming into the picture in the process, like the system level design, that is infrastructure architecture, and the programming level design. So this is going to have the specific duration, and once this is completed, so which start this, the next one is the coding or implementation. So implementation, again, we need to understand these 2 points here. So infrastructure has to be set up that, and as well as the Java developers or the .NET developers or the program developers are coming into the picture to implement the application. Two types of this, the setup. One is infrastructure team is coming that to set up this the complete infrastructure for this application requirement. That is the network settings or the storage settings or the virtual machine settings or the OS installations or the users creations. So all this will be done this. So infrastructure teams as the implementation point of view, and which is coming that, so there's implementation part at infrastructure level and implementation part at coding level. And once this phase is done, so which we have that the testing models, which we have this unit testing and integration testing. So these testings required. So there's that means evaluating of the complete functionality which is implemented or complete infrastructure which has been set up there. There is a testing approaches, and once these testings have been completed, next which we have this is the load testing or system testing. So in this phase, the performance of that application will be evaluated. That means whatever the code which they have implemented and whatever the infrastructure that has been set up, that is it supporting for this the 1 lakh users or not, or is it supporting for this one user or not. So the complete load testing or system testing is required. And once the system testing has been completed, so next which we have this is acceptance testing. The Gmail user is going to verify that, or the Google vendor is going to verify that. So all the functionalities that is delivered or not. So he's going to evaluate it. And if it is evaluated successfully, that means accepted by the Google. So all this, the login pages and everything is good. So then which we have this production environment or maintenance environment. So these are all which we have this. If we just observe the testing itself, we have the multiple phases. So integration testing. So testing engineers are going to perform all these load testing, functionality testing, integration testing. So that team is coming into the picture here. And acceptance testing, that means Google vendor is going to verify all the scenarios before releasing that application to the live environment. So acceptance testing. And finally, it has to be supported. There's the operational team which are coming into the picture. Yeah, so there are the different phases we have that, or which we consider the different life cycles. So the first requirements, then designing, then implementation. Implementation, again, we have the two sections: infrastructure setting up and as well as programming implementation. So infrastructure, who will set up this? We have the separate administrators are available. So the network administrators, the system level administrators, or we have the database administrators, middleware administrators. So this team is coming into the picture who are setting up the infrastructure for this application. And once this application is implemented, so which will be evaluated by the testing team. And once the testing team is evaluated, so there's a UAT team, they will test it, that is acceptance testing. And finally operation team which is coming to the picture. Now, so this is the complete evaluation. But in this evaluation, so if it is objective is project on time delivery and on budget point of view, so requirement started and deliver thus the project to the live environment. If everything, all these phases evaluated successfully, then there is no issue. Like all the projects are going to get successful, then we don't listen this anywhere about this. But I mean, so this particular project is like a failed, or particular project is having this the critical stage where the projects are going to have this the critical stage point of view. So we don't listen that. But actually what's happened is last 30 years, so if you just observe some statistics which are showing that is almost 1/3 of the projects are getting failed. So these are all some statistics. So last 30 years of this approach, whenever they are planning about for the project purpose, so almost 1/3 of the projects are some percentage of the projects are getting failed. That means entire project is which they have started, and there is no output of the project. And some of the projects which are making the challenges, that means almost, if you observe that, 50% of this the projects are in that challenge in the sense like they have planned that the 1 year, but because of some issues, or because of some like the communication gaps between the teams, which is extended at 1.5 year, or because of there's some other point of view, like a cost which they planned, it is $1 billion of the cost for the project, but which is extended, that's a $2 billion of the cost. So this is, I mean, this, so finally it is successful, but with some challenges. Yes, only 1/3 of the projects on average which are getting successful. Yeah, so there are some the statistics which are showing that, so the average cost overrun, time overrun, and functionality delivered on average only 67%. Yeah, so there are like some statistics which are showing about it. The projects getting failed, or projects are overcost, or the projects are the challenge projects which are happening in the current IT industry. Why it's happening that? Yeah, so every day they have planned it. So okay, from the requirements and the delivering that's the project, yes, everything they have planning. So management team is coming to the picture. So okay, they are doing that. Okay, recruiting about the architects who can design this infrastructures, who can design the programming, and the recruiting the developers who can understand these design documents and implementing about it. And they are recruiting the testing team, so who can understand this the functionality, implementation test cases, and verifying this the quality of the test cases. And so they are like the testing engineers, so they are using some tools like to perform this the complete load testing, or others, I mean the system testings. And UAT team, they are working that their side, like to test it this all the like acceptance of this project to move to this live environments. And the finally operation teams are working that, like who are supporting about this the production infrastructures, the production, like so which we have the, suppose we are asking that the Gmail application is nothing, Gmail application is running on the production infrastructure live environment. That environment keep on required to monitor about it by the users. So there's the operation teams who are working internally, so are keep on managing about this the complete infrastructure. So this team is working that. So all these teams, but a project is only one, and with objective they are working that on time deliveries is the main objective. But the last 30 years that, so we have the some challenges projects, or we have the some like, I mean the projects which are having this like the failed projects, only 1/3 of the projects. Then what about the 2/3 of the projects, why these are getting failed? Yeah, so this was that like a traditional approach. So we are trying to understand the existing problem. First we need to, so to understand the DevOps. So if we just directly jump into the DevOps, we don't understand what is the purpose of this. So now we are coming to that. Okay, existing already some projects, so which are using about these life cycles, are facing some issues. So what are those issues? So those issues, how they are planning to overcome that, that's we are trying to understand it. Yeah, so this is the actual plan which we have that. And all these so why it is happening this is, so if you just observe that, so customers, like a customer in the sense in our context, like that is a Google team, and they are giving the requirements, and the requirements are converting into the design documents, and which are understanding by the development teams and the testing teams, and they are working this in the process. And the finally, so this application is managing and monitoring by this operations teams. So what are the different teams are involving in the entire process? So main teams, like the customers, they are given the requirements, and the requirements which are understanding by the developers and testers, they are implementing and they are testing about it. And finally, this requirements is accepted, so which is managing by that operations teams as the life cycle process. If we just conclude that, so what are the main teams are working here? So the architects, like those are just like preparing the documentations. The requirements teams also just preparing the documentation, but main teams, infrastructure, who are setting up that, who are implementing this the functionality of the applications, and who are testing about this the functionality of that application, and so who are managing the applications in the infrastructure in the live environment. So these are all the main teams who are working this in the project life cycles. But what's happened thus? Why these projects are still getting failure? Yes, so there are all the manual activities which we have this in the process. These manual activities are making that uh, some communication gaps between the teams. Because of these communication gaps which are happening, that so either functionality, so which the customer is thinking about this one requirement, and which is sorry, which is understood by this the developers in the different way, and because of these requirement gaps which are happening, thus the project delivery dates are getting that impacted. So there's some communication gaps. So this is the complete manual process, and in this manual process some communication gaps are happening that. So the main teams like so the requirements understanding by the development, if something is different, then he's going to implement in one way, and which is going to the customer is expecting in different way. If there's the gap is there, then finally it is not moving to the delivery. If it is not moved, is nothing but, so they are again coming back to this the development, change the code, and again go back to this. Suppose this is the life cycle again. Suppose the customer is testing over here, acceptance testing. So whenever he verifies the change in the acceptance testing, if something is wrong, then again it is going to change to the requirements. So change the requirement, then change the design documents, then implement that, then do this all these test cases, then do this all these test cases, then show this to the customer. And if he is now, if he is satisfied with this change, then he will accept it, and which will move to that operations environment. There is a production environment. Suppose if he doesn't satisfy with the change, again it goes to the the previous stages, and again it is required to evaluate it all these stages. So this is making that in this process one of the disadvantages is the customer is not involved in that as a member. So this one main point what do you have this is the customer is giving the requirements here, and he is going to test it here. But this is the environment which is performing this in our current in our organizations, like, so there's only about internal process. This is one of the major disadvantage in this waterfall approach. And the second point what we have this is main teams what we are trying to understand is, so development team, testing teams, and then operational teams. So that's a total the four teams. All these four teams, that's the point of what do we have this is, so between the developers and testers and operation teams also we have some communication gaps. These are all like infrastructure related issues, infrastructure related gaps. And here it is requirements gaps, either requirements gaps or either infrastructure related gaps, finally which is leading that the project application delivery dates getting delayed, or on time we cannot deliver it. On time you are not able to deliver is nothing but, yes, it is making that like a project extending more. Project extended is nothing but resources cost, and like infrastructure cost, all these points also will be coming into the picture, and the cost of this the project also is going to get overrun. Yeah, these are all the gaps which we have that. So these gaps, the one is the requirements developers and testers, this is gap. And second one is developers, testers, and with the operation team gaps. How do we overcome these gaps? So the latest how they are thinking is, okay, don't go for this the old approaches. So waterfall approach is not good, because the customer is involved in this only in the requirements and then acceptance testing. He is not involved in the regularly. Make it that the client in the regular. Okay, that is going to helping that sorry, to overcome the gaps between the requirements, developers, and testers. But what's happened is, how do we overcome this, the gaps between the developers and testers operation? We'll come back to that, these points to understand separately. But first I'm talking about it. So how do we overcome the gaps, and what is the process they have launched? So in this process, like to overcome the gaps between the customer requirements and the developers and testers. So to overcome these points, so what is the approach that we have this? Have understood these points, or any queries or questions on this?
No, we are fine.
Okay, good. Yeah, so we are just trying to understand that existing systems, that existing system, they're changing about it. Whenever they are changing the existing systems to the new systems, yes, again they are facing some problems. Those problems we are going to look at that is the DevOps. So we'll come back to that, but just to understand it, the first we need to go for this understanding that the communication gaps between requirements teams, developers, and testers. So to overcome these gaps, so this is which we are trying to understand this now. So to replace these gaps, to overcome that, so what is the methodology which they have started in the project is Agile methodology. So we have this, I mean, last the 6-7 years onwards, these are all coming into the picture. But yeah, so they're changing that the older traditional methodologies to this latest traditional methodology, that is Agile methodology. Yes, so Agile. So here also, I mean, so Agile is also like as the process which we have, that the requirements, and then so take it all these requirements and group as a product, and this product divide that the small units. So the main approach what we have this is these technologies, I'll come back. So main Agile process, if we just observe that, so the complete product, the different modules they will identify. So all the product related, the different modules they will identify, and they will split into the small units. Suppose if we just try to understand this, the Gmail application. So the function, I mean, the entire Gmail application implementing that the single application in a single time is not possible. So they come up with this dividing that, okay, the first the login page module, plan for this, then go for this, there's a inbox functionality, go for the spam functionality, then go for this the sent mail functionality, or go for this the Google Talk integrating with this one. So there are our settings which we have that. So there are the different functionalities of that application, so which we can say this in our Agile terminology, there is a product backlog, that is a group of or the collection of the requirements, and all these collection of requirements which will be splitted into that the multiple or the small components. So the small user stories or small requirements, and each module which they come up with this the less duration, that means the 2 to 4 weeks, they don't go for this the long duration of the projects. So suppose login page is the module. Login page, they plan it for the 2 to 3 or 3 to 4 weeks, not more than that, on the base of the functionality dependencies. They recruit the more developers and they split it if it is the the important module and the high secure module. So they plan for this the short duration, that is 2 to 4 weeks. And these 2 to 4 weeks, like every day meetings, that is important here. In that older approach, what was that the approach? Only requirements the client is involving, and then in acceptance testing the client is involving. But between that, there is no client verifications. That is the main point. Client is not reviewing that every day because he is not about our member. In the older approach, I'm talking about the older approach. But this current Agile approach, what they have done is, so identifying this the entire product related the components and splitting this into the small components, and plan for this the let's have this the 1 week or 2 weeks or the 3 weeks or the 4 weeks, and every day ask this the client is involving in the meetings. That means Scrum meetings will call in Agile technology. There are just technologies which we should know that in the DevOps process. So everyday Scrum meetings with the customers, that means the reviewing about it, what we are implementing for him. That means if the some change is required, he is identifying immediately. He is not going to wait for this 2 months or the 3 months. So immediately on that day, on that spot, it will be identified, and which he is going to suggest it, and they are coming this tomorrow implementing that change. That means before it was everything is performed, then he is verifying that. No, not like that. If I implement it today, so to check it, then we do the testing and everything. Yeah, so this is the kind of the everyday Scrum meetings which we have that. And so the small, but here the point is sprint is one of the important terminology which we need to understand it. The sprint is that having the 2 weeks or the 3 weeks of that time as one module, and that module will be delivered like multiple sprints for this the single product and the complete product release. So the first product which will be divided into multiple modules, and all these multiple modules which will be prepared this one sprint, which is having the fixed length of the work, and that sprint which is having the scrum meetings with the development teams, testing teams, and with the clients. And so releasing that all these sprints like 2 weeks, 2 weeks, 2 weeks, the finally end of the 6 months you have the complete product as ready. Yeah, so this is the kind of the evaluation model they are coming up with that. So they are not using the old model waterfall approaches. Yeah, there are some technologies from this agile. So just we need to understand it, but we are not going to defend the agile. Because of this agile process, DevOps engineering is required. That is the point we are coming back to that. But this is just like a process they are coming up with that to overcome the gaps between the client requirements, developers, and testers. Yeah, but in this agile, what are the technologies we are trying to understand is we don't call that the requirements, we call that the user stories. And all these collection of user stories, what we call this is product backlog. That means complete product. And the complete product, what are the modules we have that's module which will be created as one sprint. The sprint which will call this as the iteration, a fixed length of the work, fixed length, that is 2 weeks or the 3 weeks, that is the sprint we call that. And each sprint is having the planning sessions. That means they need to plan for that, like so okay, the 2 weeks is required, so the developers how many days, or the testing team how many days, or the UAT team how many days, and finally so okay, verifying about it and launching to others. So the planning sessions, a team meeting in which the product owner reviews and explains each backlog items. And review sessions, that means once the sprint has been completed, they're coming back again and sitting about it. Okay, in this sprint, what are the challenges we have faced? What are the repetitive activities we have done? That repetitive activities which we are doing the manually, is it possible to go for the automations or not? So these are the review meetings. So overall sprint, how it is evaluated. Yeah, so this is the way of approach which are coming into the projects, and these are helping about it. This approach is especially agile approach is making the project faster and better with cheaper delivery. So if you just understand that, so the compare with the waterfall approach, yes, waterfall approach which are the design, the specifications, and then coding, and then like the UAT testing. And if we have this any identification in UAT, go back to that and come back once again and launch that the finally to the customer. But in that agile approach, so the complete user stories, so which will be created as one sprint. So the complete user stories which will be created as one sprint, and the sprint is completed, then it will be launched to the user. Like multiple sprints. So each sprint we are expecting all this life cycle. That means implementation, testing cases running, and launching the product. That is one small sprint. But here in the waterfall approach, so do this all these activities one by one and launch it that. But here the sprint approaches, and each sprint is having, yeah, just a minute. Yeah, the each sprint is having that, so it's a specific launching times, and there's multiple sprints and multiple launches. But in that launch, yes, what we are expecting in this one sprint is the complete code implementation and the test cases execution and UAT test cases execution and launching that. Yeah, so this is that the approach which we have this in the current projects, like as a small stories with a small duration of that, and releasing that the small sprint to the clients. But why Agile? So that's the finally, so Agile, if you just observe that, it is helping about it 459% better than the traditional methodologies. 459% better than the traditional methodologies. So where is that, like the 100%, and where is that 459%? Cost point of view, schedule point of view, productivity point of view, quality point of view, satisfaction from the customer point of view. So this is proved in the market, so which is having the like a better the percentage rate compared with that traditional methodologies. Yeah, the finally agile model they are launching to the projects, this methodology they are using. So this methodology is helping about it, yes, as to improve thus the communication gaps between the requirements developers and testers. Why? Because The customer itself is one of the member, and every day he is reviewing his requirements. But and he's as well as he's coming this with the complete sprint. In the sprint, what of this the life cycle we are expecting is prioritizing the which user story is required, that means the which requirement is required to release it, designing that, developing that, and build that. That means converting this developer's code to the server's formats, like build it and then test it. That means integration test cases or unit test cases. So run this all these test cases. So this is the complete as a continuous activities we are expecting that in one sprint. But are you going to have the only one sprint or multiple sprints? Multiple sprints. As like user stories are more sprints are coming. That more sprints are coming is nothing but in each sprint we are expecting, so prioritizing, designing, developing, building, and testing. So this is the agile process which is coming. That so to make it that the communication, better communications between the requirements teams, developers, and testers. So which team is involving in this process? Development team and test cases. So this agile model, they have come up with that to overcome the gaps between all these teams. But what's happening that still we have some more issues. What are those issues? Yes, gaps between that developers, testers, and operation team. Agile is just helping that as a client interaction more, the developers point of view, testing team point of view, and verification the point of view. But infrastructure related, there's still some gaps we have that. What is that infrastructure related gaps? Why we have these gaps? So we'll come back to this. So what are those gaps and how do we overcome these gaps? So to understand it, so before that, so let me stop this 1 minute. So do you have any queries on this, or are you able to follow that?
No queries.
No queries.
Okay, thank you. Anyone, please? Yeah. Good. Thank you for that. So yeah, now let's talk it about this. So so this agile model is helping that to have the communication gaps between the requirements teams, developers, and testers. Okay, we are happy now. The project, the success rates are good, client satisfaction is good, and cost of the projects are good. So everything is good, and the like a project's management team is also very happy with this approach. But with this agile approach, we have some more problems. What are those problems? Yes, what are those problems? Yes, every day the more sprints. So small duration of the project, like 1 week or 2 weeks or the 3 weeks. So within that the 2 weeks, you need to plan for this. There is about your code, and you need to implement about your code. And after implementing this, you need to go for that, like so preparing this the ready for that for the testing purpose. And after the testing from about the developer side, and then the testing team side the tested, then the code is ready for the release to the production team or UAT teams or the remaining infrastructure. But how you're going to manage it, these activities? As a developer, I need to implement my functionality, and I need to work on these complete continuous activities. These are all the continuous activities which are coming into the picture. Sprints are more, the more work to the developers and testers. And because of these more sprints, and finally you are releasing this about your application code to the operation teams very frequently. That means, so like the every 1 week or every 2 weeks, on the base of the sprint which is planned, we have the release to this which is planned to this infrastructure live environment. That means infrastructure team, they are keep on getting the more releases because of this agile process, because the sprint which is the small duration of the launching of this application. So with this the release process point of release process, which team is involved in that? Developers, they need to say this, my code is ready. And once the developer he says my code is ready, then the testing team, they're starting about it. Yes, boss, give us about your code which you have implemented. I will test it all the quality of the application. How you have implemented all the functionalities are as we expected, it is working or not. So this testing team is coming to the picture. So testing team is coming to the picture is nothing but operation teams. They need to support that the infrastructure, right? Development infrastructures, testing team infrastructures, and then as well as UAT infrastructure. They need to set up that every infrastructure. Who is setting the infrastructures? Operation teams. More releases are there, then they are struggling with that, setting this like the QA environment. That means the QA like infrastructure, make sure that the before testing the QA testing team about the current release, and they need to ready that UAT infrastructure for the UAT team purpose. An operation team, they need to make it the final UAT is approved. So take this application and deploy this in the live environments. So they are having the more activities, so continuous activities. So the finally the way the DevOps is coming this to understand it. So developers, they have their objectives, and testing team, they have their objectives, and operation teams, they have their objectives. Different objectives, different teams, but project is only one, which is required deliver on time with on cost or on budget. But what are the problems we have this? What are the types of the infrastructure related issues? Okay, let me just talk about this one simple example here, infrastructure related. Like a developer's entire, what are the systems which they are using, that is entirely different. So the point is, developer systems may not be same as production systems, but application is only one, and that application which is implementing by the developer, they are using the separate OSs, separate system, separate infrastructure. But application, once it is ready with all the test cases, and they are going to deploy this in the separate infrastructure, that is live environment. Live environment, what are the kind of the systems? Like you are not going to have the only one server, thousands of the servers, or the 100 or 20, 30 on the base of the project load based, which we need to consider. High availability we need to consider. Failovers required to consider. Performance of the applications required to consider. And how you have this the scaling features required to consider it in the live environments. Yeah, there are also some challenges, some points which we have this on this the live infrastructures. And the developer system, he's sitting this in one laptop and he's just implementing his functionality. Once it is completed, he's just saying that my code is ready, but that code is required to deploy finally, and it has to successfully run on the high availability infrastructures. Yeah, so this is like the production system is not the same as the development system. Because of these different systems, different types of issues, and the issue is there is nothing but that issue to resolve it, some time is required. So times, or you are asking that the more time is nothing but that is a hand the dependency on the, or it is a hand the impact on the project delivery dates. This is not the communication gap about the requirement. This is because of the infrastructure related issues, because it is tested by the developer on the development system. He has tested my code is working. But if you take it the code and if you run this on the Unix system, and Unix system throws some exception, some file paths are different, or some other activities which is not taken care, and because of that which is having some other issues. The more high secured environments, firewalls have been enabled, and the file systems like the multiple mount point systems or NFS mount point systems, they used about it, the storage point of view. But a developer system, he's using that the simple one, a D drive or C drive. Yeah, so these are all the different infrastructures which we have this for the single application, and which is leading that some communication gaps, and these communication gaps are again having the impact on this the cost of the project and revenue, I mean the cost or the delivery of the projects. Yeah, so the main point is developer, they focus on this the only the enhancements of the project. Developers will have faster turnaround, so features of the enhancements, and they don't consider about that infrastructure. But operation team objectives is different, like they mainly rewarded for uptime. That means they don't worry about that what is the functionality which is implemented by this the programmers, and they take it about this application, they go for this deploying on the live environment. So lesser turnaround, so times with respect to the deployments process, and so infrastructure. So this, I mean, this team objective is different, And finally, these different teams objectives, which are making that impacts on the revenues and impacts on the plans, impact on the support, impact on the revenues. So if there's the code which is implemented is not working on the Unix system, so that code is not useful, then it is impacting on the revenue. So there are some problems which are making that because of the infrastructure. Yeah, finally, how do we overcome these infrastructure related issues? So here, so just like to understand this, one more better example is suppose project is running on the Java, and the Java version which we are using, let's assume that 1.7. So project, so that complete code is required to run on version of Java 1.7. So live environment Java 1.7 you are using, but the developer system, so he can install that his own softwares because there are no restrictions on that. Suppose by mistake he has installed the JDK is installed, but 1.8 he has installed, or the different versions he has implemented, or he has installed in his system, and he didn't observe that what is the version he has installed in his system, and that is leading that another issue, because whatever the code he has implemented everything as per that 1.8 version in his system, and if you take this application and if you deploy this on the 1.7, and 1.7 is not supporting those features which are implemented using 1.8, again he has to go back to this the code changes, again he has to uninstall this 1.8 of the JDK, he has to install the 1.7, again he has to change the code back, again test cases run it. So this is leading that there's impact on this the delivery dates or impact on this the projects. So but how do we coordinate that the developers, testers, and operation teams? So that is the replace of this DevOps. Agile is helping that to overcome the gaps between the requirements, developers, and testers. Yeah, that is the process. Yes, and that methodology is making that the more sprint work, the small iterations, more work to the teams. Because of this work, they are not able to concentrate on this the infrastructure. They are looking at the only enhancements. But because of this concentration, which is leading to the infrastructure related issues in the live environments, and those issues are making that the project delivery dates extending or making about this the cost of the projects. So how do we coordinate or collaborate it or communicate it between the developers, testers, and operation teams with the fast delivery? So one more point here also, we are using about the fast delivery. What is the fast delivery? So once suppose the developer, he says my code is ready, and this code functionality is required to make sure that we have delivered to the production environment as fast as. Suppose the previous the older traditional approaches, the 1 week or 10 days or the 15 days or the 2 months or the 3 months, so every like 1 month we have the delivery dates. But nowadays, as a competitive world, so if I decide this one change for my application, how quickly I'm delivering or providing that feature to my customer, then I will get this the more benefit. So if you're going to take the more times to deliver the product, they don't accept it. So if the customer he's decided, okay, so launch it about the new functionality in my application, like something some like the new functionality in the Gmail application, something like unread functionality, so some new functionality, how quickly or how fastly that is they are delivering this to the customer is very, very important. Yeah, there are all the points which are making that as like the fast deliveries, better deliveries, quality of that. So how do we coordinate it in this the fast delivery approaches? So how do you coordinate it, or how do you communicate it, or how do we collaborate it, all these teams? Because you need to make sure that the infrastructures, you need to make sure about the change which is moving to the live environment, and you need to make sure that all the systems and all the test cases have been evaluated successfully or not. So how do we take care about it? So that is the solution which we have this from the DevOps. Yes, it is a combination of the development and operations, but why we are saying the development and operations will come back, and it is a software development methodology that stresses. So whenever anyone asks about this what is the DevOps is, DevOps is not the tool, or DevOps is not the like one of those the technology. So DevOps is the process. So that is a methodology. So the DevOps is that's the methodology. So which is supporting that to have the better communications, so collaborations and integration between the developers and operations teams. Yeah, so there are some principles. So principles, there are just like a high level points. You can just refer that. So finally, what are the benefits of this DevOps? Yeah, so more successfully. Now the point where we are using the DevOps, once developer he says my code is ready in the sprint. So development it, so take it about it, build it and test it and run the UAT test cases, run the production test cases and make sure that that is launched successfully. So these kind of activities related the solution, the DevOps engineer is providing that. So developers code onwards, before that we don't work it. So customers like the requirements on this, the customer's point of view would never work it, but the developer he understood the client requirements and he says my functionality I have implemented which you have given to me and my code is ready. Yes, how fastly you are delivering that code to this the live environment is important. Yeah, so in that releases, so we need to make sure that the successful releases, consistent releases, and which we are going to have this predictability integration. So there are like the benefits which are supporting about it with the DevOps process. So the DevOps, so with this DevOps, what is the life cycle we are expecting is, so once my code is ready, code take it, deploy to the servers, that is testing environment, run the test cases, and then deploy the UAT environment and run the test cases, and then deploy that application to the production environment and run the test cases. This is the continuous delivery process. Delivering that application. My code is ready. Yes, deliver this to the production environment. But in this delivery, we have the different life cycles. You should not take the developer code directly to the production environment. So that's required to have this the evaluation, that is the first performing that unit test cases execution and then integration test case executions and UAT test case executions and the production test cases executions and the load testing cases executions. All these things are done, then you can launch this about your product successfully to the customer. This is a continuous delivery process we have that, but in this continuous delivery, different environments, you are not just going to use it one day, one environment. So there's integration environments, load testing environments, UAT environments, production environments. So deploy it, test it, deploy it, test it. Yeah, finally, DevOps is helping about it continuous delivery. And if you just combine the both Agile and DevOps, yes, Agile here and the DevOps is here, but Agile is helping that as a continuous integration point of view. Suppose here multiple developers are working here on the same module. All the developers code is required to integrate it as a single project, and then this entire project code is required to build it. So make sure the builds, so that's ready, then make sure about this the testing cases or test cases have been executed. Yeah, so this is the complete the CI process we are expecting about it. So this one which we can say that continuous integration, and the DevOps, so which is helping about it the continuous delivery activities. That is once this like I mean that in the development environment and he has run his test cases and it is ready, and take it this application, deploy the next environment, run the test cases of that environment, then take it this application, deploy this in the next environment and run the test cases. So this is the continuous delivery process we are expecting that. So the finally Agile and DevOps, if you just group it these two, yeah, there are the advantages. On the diagram point of view, Agile plus DevOps is continuous integration on the development system. Make sure that you have delivered to the live environment as a continuous delivery. So what are the main terminologies that we have this in the process? By having this as Agile and with DevOps is continuous integration as a continuous delivery. CI and CD approaches will call that. So CI approaches mostly these all belong to the development environment, and once the development environment is ready, so take it thus and deliver to this all the testing environments and finally to the live environment. And once it is delivered, if something is wrong, so take the feedback and take this the review and go for this once again changing and go for this continuous deployment or the continuous testing. So here the point: continuous integration, continuous deployment, continuous testing, continuous deliveries, and continuous monitoring. These are all the daily activities which are making that the stress on the teams, developers, operation teams, and the testing team. So testing team, we have the releases is nothing but they need to keep on testing that. That's continuous testing. Operation teams, they need to keep on deliver this the project. And they need to keep on monitoring about this the infrastructure. There's a continuous monitoring, continuous delivery. And the developers, the continuous integration. That means whatever the code which they are implementing, they need to integrate with the other developers' code. And while integration, they need to make sure that all the integrations properly they are doing or not. If something is wrong, which is going to leading, that's another issue. So these are all the points: continuous deliveries, the continuous integrations, continuous monitoring, continuous the testing. So all these things, how you are going to manage it in the projects or in the process. But what about this CI and the CD? So this one we will try to understand in the next class, because so from here we need to go for this the long there's some more concepts which is going to take this around 1 hour. So which we go for this in the next class about this the one more demo understanding about what is this the continuous integration, continuous delivery, and in this continuous integration, continuous delivery. So what are the main activities as a DevOps engineer we are going to perform? That we have the 6 or 7 activities which always we need to think about this in the process. We are going to work for the process. Thinking about that, the DevOps engineer scope, how it is changing that, what is the value that we have that. You are not working this for the development team or you are not working for the testing team. So you are going to work for this the complete process point of view. Without having the process, there is no project. If the process is there, then the DevOps engineer role is there. So that's the kind of the value which is coming into the market about the DevOps engineers. That's why there's a lot of the demand for the DevOps engineers. This is not for the just only for this new project purpose you are going to set up that. Existing projects are also going to change it to that the DevOps models. Existing, how many projects we have, the thousands of the or lakhs of the projects are available. Yeah, so this is the points which I have this for today. Like understanding about this, the agile importance and understanding about the DevOps. But the DevOps, what is the points we have this is CI and CD are the CT, that is continuous testing, or CM, that is continuous monitoring. So these are all the points, but these points, how the DevOps engineer is going to work it, and what are the different tools we are going to use it from the DevOps process to define it. All this continuous integration, continuous monitoring, continuous delivery, or continuous deployment, or the continuous the testing. So what are the tools that is supporting that? Those tools we'll try to understand tomorrow. Yeah, so that's for today. So which we have this, that's the introduction about this the Agile and DevOps importance. Yeah, so any queries or the questions, so just please let me know and we'll wind up for today.
Yeah, hi Venkat. This is Rajeshwar.
Yeah, hi.
Yeah, so for monitoring, are we using, are you going to explain about Splunk?
No, Splunk, I'm not going to discuss this. We are going to discuss about the Nagios tool.
Okay.
Nagios and the AWS point of view, which we are going to discuss the CloudWatch.
Okay, okay. And so Kubernetes or Ansible?
Yeah, yes, we are going to deal with that, the Kubernetes around the 6 or 7 classes. Ansible, again, there's a 7 or 8 classes with the AWS provisioning concepts and with completely launching about this, the database servers and the monitoring servers. We have the complete Ansible, around 9 or 10 classes for the Ansible, and the Docker around 6 classes, Kubernetes around 6 or 7 classes, and the Puppet around 3 or 4 classes, and the Maven Jenkins especially, which are going to deal with the 9 or 10 classes with the complete advanced the not just like launching the tool and showing about it, okay, this is and shutting down, not that. So we are going to deal with that, how to configure the securities, how to configure that authentication authorizations, and how to define the master and slave nodes. So all those the detailed discussions we have this, and some important tools. The main tools is like the Jenkins, Ansible, Docker, Kubernetes, and AWS. With the Linux, important some of the points which are required for this as like the DevOps you need to manage it infrastructure side. So those Linux points, yeah, these are all that's which are included in the course.
Okay.
And
So,
Maven, Git itself.
yeah. Uh, do we will be involving any labs? So, are you giving any assignment type?
Yeah, yes, I mean, so that is so which so whatever I'm explaining itself is having this the kind of the assignment which are going to help us as a real time point of view. And once that activity is completed from my side, you can take it this as an assignment. I will give this points what you can go ahead and how you can set up that, and you can practice it. And if you have this any issues, the next day you can come up that and which we can discuss on that issue which are facing, and where we can go for that, like discussing on that and resolving from about your side as well as.
So, you will be guiding setup of local setup at
Yeah,
local
yes,
my PC.
yes, yes. My
So,
approach is complete. Yeah, completely from the scratch onwards, you can set up this in your system. So with complete advanced level.
okay, fine. And so, if we have AWS account, then so there will be we have a trial account for AWS.
Yes, correct,
So for
correct.
practice.
Yeah,
So
you can
that also you
parallelly
will
work
guide.
on. Yeah, so that's
Yeah.
also I will guide it, and we will see the some of the important services from the AWS as well as with the completely flow of execution. So saying this in the AWS.
Okay. Okay. Okay.
Yeah, so actually that's I would like to conclude it tomorrow. So as because that's the tools I didn't mention this today. What are the tools we are going to discuss? So tomorrow, whenever we talk it about the tools, those tools I will conclude it. Like Nagios, we are going to discuss. The Ansible, we are going to discuss that. Maven, we are going to discuss. The Git, we are going to discuss. The Jenkins, we are going to discuss. Vagrant, we are going to discuss, and as well as like the Puppet and the Linux, AWS. So they're all the tools. My approach is the slow and steady wins the race, like which I take this like around 2 months, 2 to 2.5 months is the class duration which we have this for this.
Okay. And so, so do we have any prerequisites of having knowledge on writing scripts?
Yeah, so there's a like I mean not required, but we are going to deal with the shell scripting. So those with that, which you can pick up that's like some scripting. So if you have this any programming knowledge, that is added advantage, but that is not mandatory.
Okay. Basically, we are developers, but we are not completely master in scripts.
Yeah, I mean that's which we take care about it. Some of the portions point of view on the shell scripting.
Okay. Only means apart from shell scripting, in DevOps process when we are using these many tools, so are we writing any other scripts?
Yeah, we are going to deal with that the Jenkins Groovy scripting and Ansible point of view like AML scripts, and which we are going to deal with this like the Docker and Kubernetes point of view like composers, like these are also YAML files, and we are going to deal with this the Vagrant whenever we discuss some Ruby scripts. Yeah, so on the base of the tool supported the scripts we are going to talk at that.
Okay. Okay, fine. So we can cover everything in this two and a half means I mean around 3 months. We can cover everything.
Yeah, yes, yeah, we can cover everything.
Okay, okay. Thank you.
Yeah, no problem. Yeah, anyone having any queries? Because I didn't conclude it today about this the tools point of view. So tomorrow we'll understand that. So exactly, there's a CI/CD process to implement it. What are the requirements? That's requirements. How or what are the tools we are going to talk about? So tomorrow you will be understanding that what are the tools I'm talking that. So then there I will conclude about this the each tool, how many classes that is required, and how much time we are going to spend on that. Yeah, so if it is if you don't know these tools which we discussed just now, so just wait for this the tomorrow class. That's not an issue. Yeah, anyone having any other queries, please let me know that, then we can wind up for today.
Hi, Venkat. This is Sai.
Yeah, hi Sai.
Venkat. I'm a middleware administrator. Can you tell me in
Yeah.
which way these all tools may be helpful for me? I mean, uh, there are too many tools which covers in DevOps. I don't think
Yes.
uh, every tool need to be learned by an administrator who works on some servers.
Yes, correct. Correct. But the point is that DevOps is going to helpful as an administrator if you're going to learn it. Suppose if you are working this as administrator, let me give the some scenarios. You need to deploy about your application to the some 100 servers. Then how do you deploy this one application to 100 servers? How do you automate that process?
Oh,
So
obviously,
that is the point.
slips.
Yeah, yeah, that's point of view. We have some solutions from this like the DevOps point of view. Like we have the Ansible configuration management tool. We can use it. You can suppose if you're working for the Tomcat or working for the WebLogic. So these servers you can automate it everything with these configuration management tools and infrastructure automation tools. Yeah. So the main point what do we have this is why we have all these tools. Tomorrow you will be having the clarity. Then you can understand that for about your next generation of the technology which are evaluating that, or as an administrator if you are working this in the infrastructure side or the middleware side, so how these tools are helping in the process as an administrator whenever you are working that. So tomorrow maybe I can give this there's some more points as like middleware administrator if you are working that, which tools are supporting this from about our course.
Uh, okay, fine. Thank you.
You're welcome, no problem. Yeah, so I hope so. Anyone having this, please raise the hand so then we can discuss. Everyone is good, right?
Yes.
Yeah. So thanks for the today. And tomorrow we will meet it at sharply 8 o'clock and we'll continue this 1 more hour to understand this, the next DevOps, the CI and CD process. And in the CI and CD process, what are the different tools we are going to talk it, and the each tool purpose we'll try to understand in the tomorrow class. Yeah. Thanks for the day, and we'll meet tomorrow. Thank you.
Thank you.
Thank you.
This conference will now be recorded.